Bill, I start off by saying it's a huge subject. There's no way in the world I could get over to you the development of the program, what goes in it, how digital transmissions work. So I'll try and cut it down to the interesting parts, but I'll have to touch on a little bit of the science of it to make it interesting. It's all just fun. But I'll have to have my little list here, because getting old is to get what you're going to talk about.
That's a problem.
Yeah, just a bit of my background to start with. That, computing has been my hobby since 1973, and I started off programming at that stage. And I now have programming in Delphi. I've tried all the various languages, starting off Visual Basic, C, C++, and ended up with Delphi, which is a very, very good language. You can program at low level, etc., etc. 1973, I think I was the second person who had the AmTool board operating. Erik VK4AES got the first one. That was with Peter Martinez. I later collaborated closely with Peter when we made up another program, which was a digital program that made a great whir in the world for 4 days until a better one came out and they forgot about it. Set up the first RTTY repeater in VK3, and I made many, many programs: SSTV PAL, SSTV Multinode, PSK PAL, and I closely collaborated with Mako Mori of MMSSTV. Anyone work that slow scan television or know that program?
Yeah.
It's analog. Anyhow, Mako, he was a Japanese chappie, and at that stage you were buying all these programs for about $120 each. This is where we both became very unpopular because we released it as freeware, and that really upset a lot of people. Now, the first thing I came across, the digital type of program that I've written now, was originally written in Linux, and I was able to convert it over to Windows. I think a lot of this is not very interesting for you, but anyhow, just a brief background. The actual core of the program EasyPal is a DRM core that was written in Europe by a lot of very clever people at the university, and then released commercially, and it was used for transmitting of data over bad telephone lines and things like that. Later on there was a very clever fellow called Sesko, HB9TLK, and he was able to turn the code into a DLL, which then made mere people like me able to use the various routines in it to make up programs like this. So I had a wonderful time making all these programs up. About 3 years ago we were struck by lightning fairly in the shack, which destroyed all my computer gear, destroyed all my wife's telephones, everything went. I lost all my software, and you might say I went into a bit of depression. So I didn't go near computing or programming again for a whole year. Lost everything, all those years and years of work. So I started up again with this particular program, EasyPal, and it was probably a good idea because all the mistakes that I made in the previous programs that I couldn't change, I've now been able to rectify in that. Now it's a digital program, but a little bit different to the normal digital programs. Most digital programs run on what they call ARQ, where you have handshaking between two people, but it's only limited to 2 people in contact, like PACTOR or AmTour, so it's not a fun group type of activity, whereas this is, because you don't have to, anyone can receive it. You can be in a group of 10 or 15 people and they can all receive the pictures and all talk to each other. And digital, of course, has got the great advantage that you've got error correction, which means that it's possible to get a perfect transmission, and that's what we can get. We can get, depending upon how much time you've got, you can have photographic material just amazing. You can look at the young girl there, you can send that in about 60 seconds. You can't possibly do that on other means. A little bit about the digital, why it's so good. Well, stop me if anyone wants to stop me talking about this, but most digital signals, if you see them, see a myriad of carriers. You might have 16 different carriers. If you look at them on a waterfall, which I'll show you there later, you'll see the carriers described. They're, say, carrier spaced about 100 kc apart, and they're all modulated, and there might be up to 16. And that will mean that if they interleave them, that if there's a static crash or someone talks in the middle of it, it won't destroy the information. So you can still get perfect error corrections or whatever. Now the big difference about this DRM mode compared with all the others is that where these carriers are limited to what bandwidth they have, of how high a baud rate they can sustain. So if the carriers get too wide and overlap, they all mix with each other and you've had the gone. Now this DRM is the first one that now has carriers very, very wide that all overlap, and you can get huge baud rates out of them, and they work. They don't have any problem. The way they do that, they use a time lapse. So you only look at one carrier while you don't look at the other. It doesn't exist. So you can get, well, in this one you've got 57 carriers all running together. 57 carriers, all at different frequencies, all being modulated, all overlapped, and they're all sorted out. And you'll see that when I pretend I'm transmitting something from here over there, that you've got a little set of lights on the right hand side. You can see all red, little line of red. And I've got various stages of the synchronisation to when I start transmitting the signal. So what can it do? Well, it's a file transmission type of program, and you can send any file, pictures, you can send text, you can send even exe files, and they can be received at the other end absolutely perfectly, not one single error in them. It's been used there's so much in this program, it's difficult to explain all the sequences, but there's an email facility in it where you can send emails from, say you're in a caravan park and you have no access to the internet. You can use this program to contact someone who has, where you've set up the program to access your internet, and he can receive you and through you send out an email to someone, any on the other side of the world. They can then reply and it goes back to the guy in the caravan park. Now this has been used by Mars and some of the emergency traffic overseas. And the same with the text messages, because you can have very small text messages which have absolutely total error correction and very, very fast, and that's what's being used particularly in the States. Which was rather interesting, they don't do it themselves. So here we are in a little back room in Kimpi. I guess I could go on and on with all the various things in it. I think the best thing to do now, there's not that much time, is that I'll start sending pictures and you can sit around close to that, and I'll try and explain what's going on while the picture is in progress of being received. While the picture is being received, it can have two modes of doing it. One is where there is no error correction, you might say instantaneously. The picture is sent in segments, not a continuous transmission. Each segment is part of the total file. So if there are 100 segments and 20 were busted, well, it fails. But to fix it, all you need to do in the program is send back the 20 ones that are busted. It'll remember the good bits, put it together, and you get a perfect picture.